All right, so now that we've learned how to do these problems, we're actually going to figure out how do we calculate how much we get when we do the actual chemical reaction and compare it to the amount that we really do get. And so this is called percent yield. And so basically what we're doing in percent yield is right down here, the main idea is to measure the efficiency of the chemical reaction. So what you normally calculate when you're calculating all those numbers in your reactions, you're calculating what's called the theoretical yield of that chemical reaction, but that might not be what you really get. So there's actually a lot of different reasons that you might not really get that theoretical amount from a chemical reaction. And some of those reasons are going to be that the reactants might stick to the containers. And then there's also the fact that there's different materials that are reacting with each other, and so they're competing to form different products. Okay, so there's a couple different reasons, but we're going to actually figure out what your percentage of amount being made is. So the first thing that we're going to have to make sure that we understand are the two vocabulary words you're going to see. You're going to see the word theoretical yield. Now, theoretical yield is what the maximum amount of the material could be made. So theoretical yield is really what you calculate. So all the mathematical problems that we've been doing, the theoretical yield is what you've been figuring out. The actual yield is how much you get when you actually do the chemical reaction, when you carry out the experiment. Okay? From those two numbers, from the number you calculate, which is what we've been doing all along, and then the number of what you actually get in the experiment, we can then calculate what is called the percent yield. It's kind of like calculating what your percentage on a test is. On a test, there's the theoretical amount of what you could get. So let's say I gave you a test that had 25 questions on it. That's your theoretical. You could get 25 questions on it. But then when you take the test, the actual amount is how many questions you got right. So if you think about it in terms of calculating grades, it's kind of like if you got 20 questions right on the test, that's your actual. And you had an opportunity to get 25 of them right. That's your theoretical. And then we go ahead, we multiply that by 100, and that's how you figure out what percentage it is you got on the test. It actually works the same way when you're doing these calculations for chemistry. You get your percent yield, and you can see down here your actual yield, which is what you get in the experiment. You divide that by your mathematical calculations, multiply by 100, and that gives you your percent yield. So you should see how that matches what I was doing up here. These two match, and so that's basically how you calculate it. All right, so here's your first question. The amount of product that can be formed from a given amount of reactants based on your stoichiometry calculations. Would that be your actual yield, your percentage yield, your theoretical yield, or your stoichiometric yield? Take a second, think about it. Which of these would be the amount of product that can be produced based on the given amount of reactants? And you should say that this would be your theoretical yield. All right, so let's go ahead and try one that has an actual percent yield that we have to calculate. So if we read through this problem, the first kind of step is to just pull it all apart. So it says you calculate the theoretical yield of a chemical reaction. You're starting with 50 grams of a reactant and you get 25 grams of product. We want to figure out what is the percent yield if our actual yield is 22 grams. So let's lay this all out first. We've got our actual equals 22.0 grams. Okay. Now, how much theoretical product should we have gotten? And it says right here that our theoretical product should have been 25 grams. So now we've got to make sure we set this up correctly. What could you have gotten is the 25. The theoretical goes on the bottom. So how this is calculated is actual over theoretical times 100. So if we plug this in, we're going to put 22.0 grams divided by 25.0 grams, and we're going to multiply that by 100. Okay, so when you multiply that, when you divide that, multiply it all out, you should have gotten that we had an 88% yield. So A should come up with your answer. So I think the hardest part for students is usually making sure that they know which number goes where. So the key here is remembering that your theoretical yield is going to go on the bottom. This is what we've been calculating all of the time. It's calculated from your balanced equation. The actual yield is the amount that you produce in the laboratory through your experimentation. So the key is to make sure that you know that actual goes on top, theoretical goes on the bottom, we multiply by 100, and that's how we make sure what percentage of the theoretical amount we get. All right, so next we're going to do a couple of quiz questions to see where you stand in understanding all of this. So the first one, what law are all stoichiometric calculations based on? Is it the law of definite proportions, the law of conservation of mass, the law of conservation of energy, or none of the above? You should be saying to yourself that it's the law of the conservation of mass. Okay? Remember that we've done a couple of reactions where we pointed out that however much goes in has to always be equal to the amount that comes out. And we did this when we started with a very simple reaction of water breaking down into hydrogen gas and oxygen gas. If we balance this chemical reaction, we would have to have 2 molecules of water, or 2 moles of water, and we would produce 2 moles of hydrogen gas and 1 mole of oxygen gas. So you can see that everything kind of balances. If I take the mass here of 2 moles of water, that actually would be equal to 2 moles of hydrogen gas plus 1 mole of oxygen gas. And so we've seen already that the law of conservation of mass plays into role here. Next question. The mole ratios can be determined only if what? All the reactants are present in equal amounts, so that means you have to have the equal amount of all materials that are going to be on our reactant side, over here on this side. Letter B, the reactants do not have coefficients, so that would mean that you have no numbers that are on this right here in this particular example. C, the products do not have coefficients, so that would mean no numbers on the coefficients for either of these guys. Or D, the equation is balanced. The correct answer that you should be thinking of is that the equation has to be balanced. So in order to be able to use that mole to mole ratio, if I give you a certain amount of water and we want to find out how much oxygen is produced, I can't do that if I'm using the equation that's unbalanced. If I just put H2O yields H2 plus O2, that's not going to give me a correct answer. I've got to always balance my equation first. This next problem actually looks a lot more complicated than it really is, so I'm just going to point out and highlight things as I go through it. It says, if the following reaction yields 5 moles of NaAuCN. So first thing I'm going to do is I highlighted that in red, and I'm also going to highlight it in red on my chemical reaction. So it's telling me this material right here. I've got them both highlighted in red. I'm going to change to a different color. It says how many moles of Au were present as the reactant. So I used a different color to highlight that. I'm also going to mark it on my reaction here. Now I'm starting with moles. So right away, I can actually use a mole to mole ratio. So if I were doing this problem, I'm going to start with what I'm given, 5 moles of that NaAuCN2, okay? And I need to get to moles of Au. Well, my reaction right here actually shows me it's a 4 to 4 ratio. So I can write this out, but really 4 to 4 is 1 to 1. That's going to be mean that I've got 5 moles of that reactant present. So don't let something that looks this complicated trip you up. I would definitely suggest always marking the material in the question, the material in the reaction, and then where am I going with it, and recognize that I'm already in moles and I want to get to moles, and so I can just use my mole to mole ratio right down here, and I don't really even have to do any work for this problem. Here's another problem that's very similar. I want you to pause the video, try and do it on your own, and then come back and see if you did it correctly. So, if you did it correctly, what you should come up with is, I'm going to do my highlighting like I do before, how many moles of NaCN, I'm going to highlight it in my reaction as well. I'm going to change colors to what I'm given is 5 moles of AU. I'm going to highlight it in my reaction as well, so I know exactly what I'm starting with and where I'm going to. So I'm starting with my 5 moles of AU, and I need to figure out how many moles of a different material there is. So all I'm using is my mole to molar ratio out of the chemical reaction above. So according to my chemical reaction, I highlighted it here, 4 moles of AU are needed and 8 moles of NaCN are needed. So now I work that out, 5 times 8 divided by 4, and you should get 10. Alright, the next question is just a basic vocabulary question. It says blank is the maximum amount of product that can be produced. So this is going to be the number you actually calculate, not what you get in an experiment. And you should be thinking that that is going to be our theoretical yield. Alright, so now you're ready to do some practice problems. You can open up the percent yield worksheet off of Schoology, or you can get a paper copy from up front. I would listen to me walking through the first one and follow along, and then perhaps pause the video and try to do some of them on your own, and then unpause it and continue watch me walking through the rest of them. So, on this first question, I'm going to do what I usually do, where I highlight where we're going and what we're doing here. So it says that we want to figure out the percent yield of Na2O2. We are told that we have a theoretical yield of 6.36 grams, and that what we actually get is 5.34 grams. So what I would do is I would actually lay this out. I'd put a T for myself of what my theoretical is. I put an A for myself of what my actual is. My theoretical is 6.36 grams. My actual is 5.34 grams. And so I need to use the equation that I would be taking my actual divided by my theoretical times 100, and that'll give me my percentage. So if we set that up, we should have 5.34 divided by 6.36 times 100. Take a minute, plug that into your calculator, and you should get a 83.96%. If we're doing sig figs, we would just round that to 84.0%. Okay, so now pause it, try a few on your own, and then come back and see how you did. So number 2, again, I'm going to highlight some different things. Percent yield, my theoretical 8.34, 7.36 of my actual. So I'm going to lay that out. My theoretical is 8.34. My actual is 7.36. So your setup, if you did it correctly, should be 7.36 divided by 8.34 times 100, and you should get 88.3%. Next one, slide this up. On our next one, it says to determine the percent yield, and we get a reaction where we have our actual is 39.7, and that is right here. It's actually produced, and then should get 86.9. So my theoretical then is 86.9. So your work should look like this times 100, and you'd get a percentage of 45.68% or 45.7% for the correct number of sig figs. Okay, go ahead, flip your paper over, try the other ones. All right, so number 4 on this worksheet is just like the beginning one, so check your work on that one. You should have gotten 54.84%. If you haven't tried 5, 6, and 7, pause it for a minute. I'm going to walk through them, but try to do them on your own. So in number 5, we have a percent yield of 95.7, so you can see I've got that laid out right here. We have 225 grams of SB is recovered, so that's my actual right here. We need to determine the theoretical yield. So this one is slightly different. We're going to do a little bit different math. The first thing I'm going to do is I'm going to take that 95.7 and I'm going to return it to a decimal. So remember that when we calculate this, it's actual over theoretical times 100, and that's going to equal your percentage. So I'm going to plug those numbers into this equation. So I'm going to take 22.5 over my theoretical, which I don't know, so I'm going to make that my x, and that's going to be equal to 95.7%, but because of this 100% right here, I'm going to move that decimal place back to in front. So this is once we've multiplied it by 100. So I'm going to just kind of do that extra step already. So now I've got to solve for x. When we're solving for x in a problem like this, x is on the bottom, so I'm going to multiply this side by x so that it cancels out. Multiply this side by x. So then I have to solve for x, so I have 22.5 is equal to 0.957x. So that means I need to divide this side by 0.957, and this side gets divided by 0.957, and that'll tell me what x is equal to, and you should get 235.11 grams would be your theoretical yield. Okay, if you haven't already tried 6 and 7 on your own, pause it before you continue watching and try to do them on your own. So for number 6, my actual is 22.8 grams. My percentage is 87.5%. I'm going to go ahead and change that back to the decimal right away. So that's going to be 0.875. And then my theoretical is what I want to find out. So that's going to be my x there. So I'm going to take, and 22.8 is my actual on top. My theoretical is what I don't know. And my percent yield back at a decimal is 0.875. Mathematically, I'm going to first multiply both sides by x so that my x on this side cancels out. Now I'm left with 22.8 equals 0.875. I need to solve for x, so I'm going to divide both sides by 0.875. And then I can go ahead and solve for my x then, put 22.8 divided by 0.875 into my calculator, and x should equal 26.06 grams of NaCl. That's my theoretical. Number 7, the one that has the greater success, is the one with the better percentage, so that would be group A.